Okay, this is lesson 4 of chapter 7 and we are today going to be learning about the double angle formulae, which are quite nice. So what are the double angle formulae? We're going to do sine and tan first. I'll tell you why in just a second. It's basically because cos is a bit more complicated. But the double angle formulae essentially are having, instead of sine of a plus b, it would be having sine of 2a. So that angle is being doubled. Well, that could be thought of as sine of a plus a. And so we could use the compound angle formula for it, which would be sine a cos a plus sine a cos a. So what you actually get is that sine of 2a, the double angle formula for sine, is 2 sine a cos a. Okay, nice and easy. There's no tidying up you can do with that. You can't do anything really great with it, but that's it. Okay, it is useful. It's really handy for something, but just yet, that's kind of as simple as it gets. Next, we've got tan of 2a. Again, that can be thought of as tan of a plus a. Or tan of a plus a would be equal to tan of a. When it's a plus, you've got a plus. So you've got tan of a plus tan of a over 1 subtract tan of a multiplied by tan of a, which will be tan squared a. Okay, and what you actually end up with is 2 tan a over 1 subtract tan squared a. And that's the double angle formula for tan. Okay, so you've got tan of 2a. Alright, now moving on from that, we're going to move on to cos. Now cos is a little bit more interesting. It doesn't start off looking like it's going to be kind of any more deep than the other ones, but it does have some depth to it, and we'll have a look at what that is in just a sec. But we've got cos of 2a, which will be equal to cos of a plus a, and of course that will be cos a cos b. Remember, if this is a plus, we use a minus, and we'll get sine a. Whoops, that should be an a there, pardon me. Sine a, sine a. Okay, so you get cos a, sine a, sine a. And what that ends up looking like is this. You get cos squared a minus sine squared a. Now that there is one of the double angle formulas for cos, but actually cos has got 3 double angle formulas. Okay, remember from year 1, you should know that cos squared a plus sine squared a is equal to 1. And so therefore cos squared a is equal to 1 minus sine squared a. Now if we plug that into the double angle formula, okay, we will end up with 1 minus sine squared a minus sine squared a, which is 1 minus 2 sine squared a. Okay, and that is another double angle formula for cos. It's weirdly enough because you've got cos of 2a and this thing only includes sine, which is pretty interesting and very handy, but it's interesting. Okay, next we know that if you had cos squared a plus sine squared a, that was a year 1 formula, equals 1, and this time I'm going to isolate sine squared. Okay, so I'll get, well, sine squared a is going to equal 1 minus cos squared a. Now in this case that's going to be cos squared a minus, if we plug into there, watch out, be careful, you're going to need to have 1 minus cos squared a inside these brackets, and be careful with that negative. You'll actually end up with the negative multiplied by the negative is going to end up with positive, and so you're going to end up with 2 cos squared a minus 1, being another of the double angle formulas for cos. So cos has got 3, sine's got 1, and tan has got 1. Cos is the most interesting one. Okay, here they are. You should pause the video. I'll give you a second to pause the video. Make sure that you've got those written down, and I would suggest putting them on some scrap paper so that you can have them as you move them through your book. But make sure that you've got them and make sure that they're really clear. You might also want to start developing a formula page because we're starting to get a lot more of them at the moment. Okay. Here's an application. You're going to see 3 applications during this lesson before I give you some stuff to do. So you've got cos squared of 40 minus sine squared of 40 is a single trigonometric ratio. Well, let's take a look back at these. Cos squared of 40 minus sine squared of 40. It's clearly to do with that, isn't it? Okay. cos of 2a equals cos squared a minus sine squared a. And what's a good idea is to write cos of 2a is equal to cos squared a minus sine squared a. And then compare it against what you've actually got in the question, which is cos squared 40 minus sine squared 40. It's obvious in this case that a is 40. It's really, really obvious. But every so often you can have something that looks a little bit more difficult, and you'll see that over the next couple of questions. So a is equal to 40, so therefore cos of 2 times by 40 is equal to that stuff. And so therefore this is equal to cos of 80 is equal to that stuff, which is the question. That is called a single trigonometric ratio. You've just got cos, or you've just got sine, or you've just got tan. You haven't got, say, cos squared plus cos or anything like that. You've just got a single thing. You've got cos of 80. Okay, moving on. Express 4 tan of pi over 7 over 2 minus 2 tan of pi over 7. Okay, well, the tan formula was, we had tan of 2a was equal to 2 tan a over 1 minus tan a, tan squared a, pardon me. Okay, well, that doesn't quite match up to this. There's some differences. Obviously, we can see that the 4 is there when we'd normally expect it to be a 2. So take a look at the question that you've got. You've got 4 tan of pi over 7 over 2 minus 2 tan of pi over 7. And force that 2 there. Force it to have a 2 in the top left section. If you force it to have a 2 in the top left section and this doesn't end up being a 1, well, it's not a double angles formula, it just doesn't work. If they want it to be a double angle formula, it will. So we've got 2 lots of 2 tan of pi over 7 over 1 minus, oh, that should be a squared there. That should be a squared in the question as well, pardon me. Tan squared of pi over 7. Okay? And what we end up with is 2 lots of tan of 2 lots of a. And a in this case is pretty clearly going to be pi over 7. Okay, and so just tidy it around so you get 2 tan of 2 pi over 7. Okay, moving on. This one looks a lot more difficult because of the fact that you've got 8 sine squared. That looks fine, but we've got cot being involved in it, which is a bit annoying really, to be fair. Now, the only double angle formulas that you've got are to do with sine, cos and tan, and so there's no point in having a cot in there. So we're going to have to simplify this stuff before we even try to get started with the trig ratio. So I know that I've got 8 sine squared 40, lots of cos of 40 over sine of 40. Okay, the sine squared and the sine, there'll be a bit of cancelling there, and what you'll end up with is going to be 8 sine 40 cos 40. It's not overly complicated to find. Now take a look back at the double angle formulas. I've got 8 sine 40 cos 40. We had 8 sine 40 cos 40. Now people can get really confused and they can think, oh well, it must have something to do with cos because things tend to have something to do with cos. Well, cos has got squared in it. It's the one without squared. It's obviously that one, isn't it? Okay, so we know that it's going to be to do with sine of 2a. Now, sine of 2a is equal to 2 sine a cos a. But that's not what this looks like just yet. This has got an 8 here, and this has got a 2. So I'm going to turn it into 4 lots of 2 sine 40 cos 40. Just forcing that coefficient there that I wanted. Now that will be 4 lots of, well, 2 sine of 40 cos of 40 must be sine of 2 lots of 40. So that'll be sine of 2 times by 40. Going to be 4 sine 80. Job done. Okay, there's some applications and the proofs of the double angle formulae. They're interesting, they're not overly complicated, but they're used for some stuff that can be quite difficult, so they're very, very important that you get a bit of practice on them. Speaking of practice, here's your tasks I'd like you to have a go at in the Edexcel Year 2 book. think it's on page 172 to 173. It's exercise 7C. It's somewhere around there anyway. Questions are 4A, 4D, 4G, 6, 7A, 7D, 7G, and if you want an extension, 7H and 7I. Okay, there's obviously question 5 and some other bits of question 4. If you want to get some extra practice, feel free, but those are the minimum. Please upload them onto Google Classroom, mark your work. Hopefully it will be easy enough. Let me know if you don't know how to do something. Thanks very much.